This and this are great descriptions of some circles, but not all circles are so convenient in that they are centered around the origin. Oftentimes, we get to choose the origin to be the center of the circle, which makes our equation for our circles, or our representations of our circles, a little nicer. But oftentimes, we'll deal with circles that are centered elsewhere. It's not too much work to deal with these circles that are centered elsewhere. And in particular, I want to emphasize there's no need to memorize anything in terms of dealing with these circles that are centered elsewhere. Just remember this sort of description of what we really mean by a circle centered at a point, and use that description to write down the formula when you need it. What do I mean by this? Well, if we're talking about a circle centered around HK with radius r, then I can write this sort of description. I have the set of points xy such that xy is r units away from this point hk. Now, from here, I can just make some observations about the distances involved and write down my equation. In particular, I have some distance equal r. And what is this distance that I'm talking about? Well, it's the distance from xy to hk. So we can just visualize the right triangle on the coordinate system that we get by connecting xy to hk. And we find that the hypotenuse of that right triangle is the distance between x and h squared plus the distance between y and k squared. This x minus h is the distance from h to x, and this y minus k is the distance from k to y. So again, squaring both sides, we get a slightly more general standard form for a circle. So we have our three representations for a circle. We have our visual, our equation, and our set notation. Here, for circles centered around the origin, and here for circles centered around any point hk.